So let's see, Jane works due north of home, and her husband Alan works due east. So they leave work at the same time, so assuming that they live in the same house, let's draw this. Let's say here's their house. Jane goes straight north, and Alan, he goes straight east, right? So we've got east and north. So Jane's somewhere around here, and Alan somewhere over here, right? So here's Jane, here's Alan. And now we're told that by the time Jane is 7 miles from home, all right, so here's home. Jane goes 7 miles, so let's write that down. So Jane's 7 miles from home. What do we know? The distance between them. All right, now here's the distance between them. Here's Jane, here's Alan, and the distance between them is this distance right here, right? That's how far they are apart. That is the distance between them. And what we know is that this distance right here, right, the distance between them is 1 mile more than, all right, there's that more than thing going on. So what comes after more than? Alan's distance from home. And that's what we're going to let x equal. So let's let x equals Alan's distance from home. So if x is Alan's distance from home, then the distance between them, right here, is 1 mile more. So 1 mile more, that's an x plus 1. And now we can use the Pythagorean theorem because we have here a right triangle, and the Pythagorean theorem says that square of that side plus the square of this side is equal to the square of that length between them, the hypotenuse. Let's write it. So we'll get the square of this side, which is 7 squared, plus the square of this side, x squared, and that's all equal to the square of the hypotenuse, so that'll be an x plus 1 squared. Let's simplify, so we'll get 49 plus x squared equals, now on the right side, here's our pattern, right? Square the first, multiply the two together, 1x, double it, 2x, square the last, plus 1. So it looks like it's quadratic. We got a squared here and a squared here, but if we decide on a side, either side, we're going to subtract x squared. And when we do that, if we subtract the x squared, on the left side, x squared minus x squared is 0. On the right side is 0. So the x squareds are gone, and we end up with 49 equals 2x plus 1. Let's subtract 1, so we'll get 48 equals 2x. Divide by 2, I'll do it right here. X is equal to 24. And the question here is, how far from home is Alan? How far from home is Alan? Well, look, we got an x. Follow it all the way back. What is x? X is the distance between Alan and his home. And that's exactly what we're looking for. So we're going to write here as our solution, how far is Alan from home? He's 24 miles from home. Let's give this last word problem, number 36, a try. What we have is a ladder leaning against a building. We can draw that. Let's do that right now. Let's just draw that. Here's a building. Make that solid. And then here's a ladder leaning against it. All right, so this is the ground. And let's put a ladder leaning against this building. Now, what do we know? The distance from the bottom of the ladder to the building, the distance from the bottom of the ladder, I guess that's right here, to the building, that distance right there, right? The distance from the bottom of the ladder here to the building is 20 feet less than, okay, here's that less than. So what follows it? The length of the ladder. So that's going to be our x. So let's represent the length of the ladder with x. And then we know this, right? We know that the distance from the bottom of the ladder here to the building is 20 feet less than the length of the ladder. So we start here with the x, and it's 20 feet less, so that's going to be x minus 20. I'm going to make that a little bit clearer here. So that's going to be x minus 20. And now what else do we know? says this, how high up the side of the building? So how high up the side of the building is the top of the ladder? So how high is that? What's that distance? If that distance is 10 feet less than, there's the less than, the length of the ladder. So the length of the ladder comes second, that's x. So this side here is going to be x, but it's 10 feet less, so minus 10. Pythagorean theorem. Square this side plus square that side, and we'll get the hypotenuse squared. So let's do that. Do it right here. We're going to get x minus 10 squared plus x minus 20 squared. That'll be the square of the hypotenuse, x squared. Let's run through our patterns here. We'll get x squared minus, multiply them together, we get negative 10x, double it, negative 20x, and then square the last, plus 100, plus this one here, square the first, x squared, multiply the two together, that's negative 20x, double it, minus 40x, and then square the last. Negative 20 times negative 20 is plus 400. That's all equal to x squared. And now on the left side, we get an x squared plus an x squared, so we're going to get two of those. We get 2x squareds. Then we've got negative 20x minus 40x is minus 60x. And then we've got 100 plus a 400, well that's a 500. And that's all that x squared on the right. So this is quadratic. We have two squares on the x squared is on the left side, only one on the right. So let's subtract this. Let's subtract that x squared. So let's just do it. 2x squared minus x squared is x squared, and then minus 60x plus 500 equals 0. And let's try to factor this. How about something, don't forget to equal 0. X and x. Now, you know, because this is 500, we're going to have to maybe think a little bit on this one. So how about if we try this? You know what, I'll do this way up here. It's going to be 500 times 1. Well, that's not going to work, right? We can't get a 60 out of 501. It's even, 500 is even, cut in half and double. How about 250 and 2? Let's cut in half and double, 125 and 4. Now I'm going to divide this by 5. It's not even, so I'm not going to cut in half and double, but I can divide by 5, in which case I'll get 25 and 20. Now the 20 is even. I'm going to cut that in half and double this one. So if I do that, I'm going to get a 10 here and double this one. I'll get 50. Well, look at that. 50 and 10. That 50 and 10, we can get a 60 out of that. So let's see what we can write here. So let's put in a 50 and a 10. The 500 is positive. So these two numbers have the same sign, which is going to be that middle minus sign. And we'll get two solutions out of this. We'll get 50, and then we'll get 10. Now, this is a word problem, so we have to check. Let's go back and look what x is. Go all the way back to the top. What was x? It was the length of the ladder. So x is the length of the ladder. So what I'm going to do is I'm going to come down here and see what I have. What if the length of the ladder is 50? Okay, if x is 50, I put that in here, I get 40, so the height would be 40, and here would be 50 minus 20 is 30. All right, that seems reasonable, so the 50 looks okay. What about the 10? If I put the 10 back in here, I get 10 minus 10 is 0. That means the height of the building to the top of the ladder is 0, and even worse, down here if I put in 10, I get 10 minus 20 is negative 10. You know, this 10 is just not going to work. So we're going to just state now that x is equal to 50. I mean, both of these numbers work in our equation, but only one of them works in our problem. So what's the question here? The question is, how high up the building is the top of the ladder? How high up the building is the top of the ladder? So that's what we're looking for. So how high up the building is the top of the ladder? Well, if x is equal to 50, x minus 10 is equal to 50 minus 10. How about 40 feet?